Hello there. So in today's edition of Problem Solving with Haskell, we are doing or attempting to solve another HackerRank problem. This one's called Between Two Sets. It's another easy problem, so it's nothing too difficult. But I've chosen this problem because I think it can demonstrate a few neat features in Haskell. So that's why I thought we should do this problem. So it's a simple problem. We are given two arrays of integers, so array A and array B, and the values of those arrays are between 1 and 100, right? So they're not too big values, small values. What we want to do is we want to find the number of integers that satisfy these two conditions. So the first condition is that the elements of the first array are all factors of the integer being considered. And the second condition is that the integer being considered is a factor of all elements of the second array. So let's look at an example. So in this case, the two integers are the first integer, the two arrays are the first array is 2, 4, and the second array is 16, 32, and 96, right? So we want to find out number of integers whose that can be divided by all the elements of this first array. Right, so for example, integer 4, it can be divided by 2 as well as it can be divided by 4. So it satisfies the first condition. The second condition for the integers that we want to find is that it should be able to divide all the integers of the second array. That is, it should be a factor of all the integers of the second array. So again, 4 satisfies this condition because 4 divides 16, 32, and 96. So if you look at all the integers, there are just three integers that satisfy these two conditions. That's why the output is supposed to be 4. So that's what the problem is. We can look at another example over here. So if A is 2, 6 and B is 24, 36, then there are two numbers that satisfy these two conditions. The first number is 6 because 6 can be divided by 2 and 6 both, and 6 divides 24 and 36. The other number is 12 because 12 can be divided by 2 as well as 6, and 12 divides 24 and 36. So the answer is 2 for this example. Okay, so let's see how we can solve this problem in Haskell. So we have our editor open here. Let's call our function f. And what we want to do is we're given two lists of integers. So these are our input arrays, right? So we're given two integer arrays, and we want to find the number of integers that satisfy the two conditions in the problem. So if we just think about the problem a little bit more, let's take this example again. So 2 and 4, and the second array is 16, 32, 96, right? So any number, so the first condition is that the elements of the first array should divide our integer, right? That means the integer that would satisfy condition number 1 has to be bigger, has to be at least as large as the largest element of first array, right? Because if it's, so in this case, the largest element of the first array is 4, and if we consider any integer smaller than 4, this 4 won't be able to divide it, right? Because it's larger than that integer. So we can discard any integer that is smaller than the largest integer in the first array. The second condition for our integers is that it should be able to divide all the elements of the second array. So this can help us come up with another condition on our on the integers that we want to consider, and the condition is that any integer which is greater than the smallest value of the second integer won't work either, because it wouldn't be able to divide this smallest element of the second array, right? So in this case, any integer greater than 16, so 17 onwards, it wouldn't satisfy condition number 2 because it cannot divide 16 because it is smaller than itself. So therefore we only need to consider integers starting from the maximum element in integer in array 1 and until the minimum element in array 2, right? So let's write that in code. In Haskell, what you can do is so let's create a candidate list of all the integers that we want to consider. So as I said, we want to start from the maximum element of first array. Let's call these arrays xs and ys. So we're going to go maximum of x's, so that's where we start, and we're going to go until minimum of y's. So you can use this double dot notation to sort of create a list between that contains elements between a range. So we go from maximum of x's until the minimum of y's, and we want to basically check for elements of this list. We want to check if they satisfy the two conditions, right? So I can do this sort of syntax to take out a value for consideration one by one. So let's call this value I. So what this syntax means is that I am creating a list from maximum of x's to minimum of y's, and then I am taking out one element at a time from this list, and I'm binding that to this variable I. And now I can do some operation on this I over here. So the operation we want to do is we want to check if it's valid. So if it's not valid, then we can just filter it out, right? So we can in this syntax we can also add filters. So the way you add filters is that you just add a comma, and then you define your predicate or your filter after that. So let's say we have a function called isValid, which will basically check if this integer I is valid or it is valid or not. Basically, isValid means that if it's valid, then it satisfies the two conditions. And over here you can just then take the element. So this notation, basically it will create a list, take one element out of it at a time, apply this filter on that element, and if the filter is satisfied, then it's gonna put the element in the list that we are producing. So this is known as list comprehension. It is supported in many other languages as well, such as Python and I think also Scala. And what we're gonna do is we're gonna find the length of this list, right? Because we're gonna find the number of integers that satisfy the two conditions. So now all that's left is for us to define this isValid function. So I can define it here after this where keyword. We can define functions. So I'm defining isValid function for an integer I, and now we're going to check if it satisfies the two conditions. The first condition is that all the elements of the first array should be able to divide I. So I can again use this list comprehension to do so. So we're going to find, and we want to extract one element at a time from list xs. And to check if it divides I or not, we can just use the modulo function. So if we do I mod x, that should be equals to 0, right? For x to divide I. So this is going to produce a list of booleans, and we want list of just all true values, right? Only then I is valid. So we can use the all function. So all function, if you look at the signature of all function over here, it takes a function that takes an element a and produces a Boolean value, and then it takes a list of a's and then it produces a Boolean value. So what it does is it's going to basically apply this function to each value in this list, and it will return true if all the elements return true, otherwise it will return false. So that's what we want. We want all the elements of x's to satisfy this condition, right? And then similarly, we want to do the same thing for the other array. So we can do and we can again do all id. We can extract one element at a time from the list ys, but this time this condition is reversed, right? So remember, the condition 2 is that I should be able to divide every element in the second array. So we do y mod I equals to 0, and that's it. This is our function. Let's see if it compiles. So I'm just going to go to gHCI and do a load of this file. Okay, it does compile. Let's try a few inputs to this function. So I can maybe try this one, 2, 4, and 16, 32, 96. 2, 4, 16, 32, 96. Okay, the answer is 3, right? So it's correct. That's the expected output. We can try the other example given over here as well. So 2, 6, and 24, 36. 2, 6, and we got 24, 36. And as expected, the result is 2. Okay, now we can define our main function. So remember in HackerRank, the output, so the input is given to us as well 3 lines of numbers. So we can just discard this first line. The first line basically tells how many elements the first array has and how many elements the second array has. We don't really need that because the functions that we use in Haskell are smart. So what we'll do is we will read this input as a string, and then we would split the input into a list of strings so that we have 3 lines, line number 1, line number 2, and line number 3. Then we will skip over the first line and we'll process these 2 lines. So let's see how that can be done. We wanna first call lines function. So lines function takes a string and then returns a list of strings. So basically it splits the string by new line character and gives you lines in a list. So that's what we want. We want to do lines, and then we want to basically skip over the first element. So I can just do tail, and now we have a list of 2 lines, and these are still strings, so we want to convert these to a list of integers so that we can feed those lists to our function f. So to do that, I can map over each element or each element of this list, so basically each line as a string, and I wanna, so these lines are numbers separated by spaces, right? So we can use words function to split these numbers into a list of strings, right? So I can call words over here, and then I want to convert each word, right? So if I call words on this, I'm going to get a list of 2 integers, 2 and 4, and then I want to convert each of those integers into int. Right now they're strings, so to convert them into string I can use the read function, but I want to apply the read function to each element of the lines, so I'm going to have to do another map over here. So I apply read on each word. That's what's happening over here inside this bracket. Okay, so now we have a list of integer lists, and this list contains exactly two elements or 2 lists, and now we want to apply the f function to these 2 elements, right? But these 2 elements are currently inside a list, so we don't have direct access to them yet. What we can do is we can pattern match on this list and extract these 2 elements. So maybe I can write it like this. So I'm using this lambda notation to define a function, and this function basically pattern matches the input list and extracts the 2 elements from that list. And I want to put these 2 elements in a tuple, and you'll see in a moment why that's useful. So right now we have the 2 arrays, x's and y's, in a tuple, and now we are ready to apply the f function of this. So Haskell has a useful function called uncurry. Uncurry, if you see the type signature over here, uncurry takes a function that takes 2 arguments, say a and b, and then produces a result, and it transforms this function into a function that takes a single argument, which is a tuple of a and b, and then produces the same result. So it's the same function, but instead of having 2 separate arguments, which need to be passed one by one, we have a single argument, which is a tuple of the two values. So it's useful in conditions such as this, where we are composing, when we want to compose a function that takes more than one argument. So you can just use uncurry to make it take one argument instead of more than one, instead of two arguments in this case. So I do uncurry f, and now f would be applied to the two integer arrays or integer lists, and we'll have an integer as the output of this function. And we just need to print that to stdout, so I just use show. So show would convert that to a string, and we can pass all of this to interact. So remember that interact is a function that takes a function that converts an input string into an output string and does an IO action on this. So what it will do is it will read the input from standard input as a string, would apply this function on that input, and then the string output that this function produces would be interact would like print that output to or send it to standard output. So that's exactly what we want in HackerRank, because we want to print the output to the standard output. So we are done at this moment. I can check if this compiles. Okay, it does not compile. It says main is applied to too few arguments. Why is that? Interact, show, and curry. Yeah, I don't see what the problem is. Probable cause. Main is applied to too few arguments. I think there is something wrong with my f function. Oh, no. Interact, show. Oh, it did. It compiled, unlike magic. Okay, I think I had like a weird character in there. So we can prettify this a little bit. We can write this like so that you can see the pipeline more neatly. So now you can see the whole pipeline here, and we can try to compile this. Yeah. Let's see if this works on HackerRank. So this is the template that they have provided for Haskell, which is crazy. I'm just going to delete all of this and paste our solution here, and we can now run the code and see if it works. Okay, so it worked for the two test cases that they have provided. I can just now submit to test it on all the test cases. Okay, and sure enough, it works for all the test cases. So yeah, we saw in this problem a few neat features of Haskell. One more thing we could do is, so we're using this ID function over here. So remember, all function takes a predicate and a list. So it applies this predicate on all elements of this list, and basically checks if the predicate passes on all the elements of the list or not. So I was passing it a list of booleans because I was doing the check over here in my list comprehension. So this function that all needs, I just passed identity function ID, and ID function just takes an input and just returns the same input as the output. So it doesn't do anything on the input, and that's what we want here because we already have a list of booleans. But we can also write this in a different way. So we can actually pass it a real predicate, and a predicate would be, so see, our predicate is basically that I mod x should be equals to 0. So I can do mod I. So I can partially apply mod function on I. So now it will take one more argument, which will come from the list. And then the modulo should be equals to 0. So we compose this equals 0 predicate on this, and I can just pass x's over here next. And we can do the same thing for this other branch as well. But it wouldn't be exactly the same as this one, because here we don't have we have y mod I and not I mod y, so the arguments to mod need to be flipped. So we can't just do mod I, because that would end up doing I mod y and not y mod I. So we can flip the mod function so that I becomes the second argument to mod instead of first, and the first argument would be the y that would come from the list y's. So if you look at flip functions signature, you can see that it takes a function that takes two arguments, a and b, in that order, and produces a result c, and returns a new function that takes arguments b and a in that order and produces a result c. So it's the same function, does the same thing, however the arguments of the function are now in reversed order. So instead of a and b in that order, now the order is b and a. So that's exactly what we want to do with the mod function. And then the equals 0 predicate remains the same, and then we can remove this list and have y's over here. So let's see if this compiles. Yeah, it does compile. We can just try this on HackerRank really quickly. So run code. Okay, it does work for the 2 test cases, and then it would probably work for all those test cases. Yeah, so it does work for all test cases. Okay, so that's it for today's problem. I will catch you guys in the next one. So until then, bye.